So what I want to explain in this video is, I think, is a phenomena and not a illusion as is termed in the original video. As a phenomena is a like a situation which is answered, right? And a illusion is something that is uh, deceptive, right? It is one thing and it looks like another. So I think the thing that I'm going to explain is rather a phenomena and not an illusion. So this is the event that I was talking about, and as you can see, the rod actually traces a curvy kind of structure, which is not like intuitive, right? Because you might think the rod is linear, and since it's just rotating, it should form some straight line, maybe of some different length, obviously of some different length. But that's not the case with this, right? You see a curvy kind of structure. So why is that? Well, a part of it is really related to the circle on which it is rotating. A part of it is really related to what angle it makes with various like the various parameters. But the root cause is like uh, not every point on that rod is moving with the same um velocity or even with the same speed. Like they are tracing different trajectories, right? If they uh, move in different trajectories, you cannot just have some like projection of that on some plain sheet of paper, plain sheet, and then find the the structure that it would form. Like you cannot expect it to be a straight line, right? um, yeah, that's what we're going to be looking at right now. So here I have just enlarged that particular picture, and I have like bought it to some third party app. I'm not third party app, like the system app, the notes to tell what I want to tell. So here you can see this is a plate, right? And this is the rod that we are talking about. What what does uh, what does this rotating do to the rod when you process this seat? Well, the thing is, when the rod crosses this seat, it it just uh, um, notes down its height and its distance from their common center. So this point where it crosses this seat actually determines the particular height. In my case, that would be like y, and let me change my color, and this distance in my case would be x. So this two is the only thing that the rotation does to the seat, like the effect of it on the seat, right? So is it necessary for the rod to actually rotate for us to find the height and the radial distance? The answer is no, and obviously no, right? And the rod can be anywhere, and the only thing that would matter is like uh, a particular point's distance from the surface and its distance radially from the common center. That way we can find the exact point where this point will actually hit this surface. uh, because why is that? Because everything uh, everything on this rod actually moves in a circle, right? In a closed circle, and the circle's radius stays the same, and so does the center, and so does its plane, because this rod is rigidly fixed onto this surface. Let me clear that up. So in the next slide, for the next portion of the video, I will try to find out what's as we go along this rod, what's the radial distance of the point from the center in relation to the distance uh, to the distance from the base, like from in relation to this distance. And then I will find out what's the height of this portion with in relation to this length. And after finding both of them, I will just uh, have to uh, eliminate this and write this in terms of this, or this in terms of this, and that would give something, that would give a function within relation to r and x, r and y, because this is y and this is x. So that will give the relation this is r, so that would give the relation in between r and y. And and just for the sake of convenience, I have taken this plane as to be in xy plane, to be xy plane. That way this radial distance in this plane would be x, and the height will as it is be y. So let's go to the next. Well, this is the photo that I was showing earlier. The video related to that was also shown. When you see it from when you see this platform from above, this platform from above, you will see a circle, right? Like a circular platform with uh, purple color rod standing like this. For the sake of convenience, we may not consider the rod to be that long. We will consider the rod to be like this long, but this long maybe, and with initial distance of around of d from the center, and then its projection length being this length being L cos theta, cos phi, maybe, or maybe cos theta. Let's write cos theta only, because I wanted to write phi because theta is not taken as normal angle in Desmos. I wanted to show you something in Desmos, but let's take theta, L cos theta. Whether you could have guessed that the length of the rod is actually L. This is the length of the rod. I'm displaying the rod like this. Now, the first thing that I would like to find is the radial distance of this of a point on the rod from the common center. How should I do that? Well, I think you have heard of the cosine formula, right? If this is d again, and the angle between them is like phi, for our sake of convenience, and the length that we're considering is maybe at a distance of let's say x, then cosine formula states x square plus d square plus 2dx cos phi under root is equal to the distance, maybe radial distance to be specific. Let's do exactly that in our case. And just looking at this diagram, don't think in your mind that the value of phi is 90 degree, like I've drawn it for the sake of convenience only. Let's find the radial distance now. I'll change my color, change my pen, change everything right now. Done. Okay, let us find at a distance of maybe, this is full length is L cos theta. Let's find a distance of maybe not y, z cos theta. Okay, so z cos theta whole square plus d square plus excuse me 2 dz cos theta. Sorry for that, I had a problem of not drinking enough water. So this into the right somewhere to I'm writing it under like this cos phi under root is equal to the radial distance. Okay, let's just keep that in mind. We will need that for our final answer. Now, at a distance of z along the rod, what's the height? How do you go about finding that? Well, when you look the rod, like your side being perpendicular to the plane, uh, like you can, okay, you can just say that I'm drawing a diagram. Okay, so I mean, just look at here. Assume that you are looking from maybe right here. Assume you are looking from here. What you will see is actually uh, a line on some circular like stadium, and it's rotating like that. Okay, and this yeah, you want to see that. Okay, this angle is what I have assumed to be theta, and when you see it from above, this angle is what I have assumed to be phi. So at a distance of z along the rod, the height is actually z sine theta. Okay, so remember that I have said earlier that we will assume the height as y. So I'm writing z sine theta is equal to y. This is one of the substitutions that I needed. Now look at this formula. Here d is a constant, z we will change right now, z again we will change right now. So let's find out. And again I will substitute r for x, because we consider xy plane as this metallic shape being xy plane. Yeah, so let's do that. For that I will need to copy this whole thing and bring it down. Just sorry for that again.